Okay, so this is for University of St. Thomas, Math 005. This is Lesson 8, Part 3. And I wanted to just go over real briefly some systems of linear equations. There's two ways that we generally get rid of or sort out what our variables would be. One is called elimination, which is pretty much what it sounds like. We figure out a way to get one or the other of the variables to disappear out of the equation and solve for it. And then we figure out what the other number would have been, going back, putting that first number back in. The other is substitution, where we're told one thing is related to another in a particular way, and we're able to find a solution that way. So in this first case, I have 3x minus 2y equals 7, and then I have a 6x plus 5y equals negative 4. And I'm choosing to go with elimination here. Usually there's one way or the other that will lend itself to solution. In this particular case, if I multiply through that first line by a negative 2, my x's are going to go to completely to 0, which is what I want. So I multiply through by that negative 2. I get negative 6x plus 4y is going to equal a negative 14. And that will be added to my 6x plus 5y equals negative 4. And when I get rid of my x's, which is what I wanted, that's going to leave me with 9y equals negative 18, or y equals a negative 2. Now at this point, I plug back that negative 2 in where I had a y in that first line. So now I've got 3x. If you take a look, I'm going back to that very first line on there of the system of equations. 3x minus 2 times negative 2 is going to give me 7. Well, 3 times 4, or 3 times x plus 4 is going to give me a 7. I subtract that 4 to the other side. That leaves me 3x equals 3, which means my x is going to equal 1. So my ordered pair, and this is what's important, this is telling us where these two lines cross. They cross at the point 1, negative 2. Now, we can also go with substitution. In this case, this is the way that it would most likely lends itself. Our y equals this other thing in terms of x, right? In this case, we have 2x plus 3y equals negative 5, but then we're told what y is in terms of x. So what I'm going to do is wherever I see a y, I'm going to replace it with this thing that we said it was equal to. So this 2x plus 9 gets put in place of this y here. So that gives me 2x plus 3 times 2y plus 9. So that 3 is multiplying that whole quantity. And then that's going to equal negative 5. When I go ahead and do that, I wind up with an 8x plus 27 equals negative 5. When I subtract my 27 to the other side, I get 8x equals negative 32, which means my x has to equal negative 4. Plugging my negative 4 into that equation, y equals 2x plus 9, I get 2 times negative 4 plus 9 is going to give me negative 8 plus 9 is 1. And so that's going to be that point. My point there where they intersect is going to be negative 4 plus 1, or negative 4 and 1. In this case, I wanted to do this one even though I've kind of already shown you how to do both of those. I wanted to point this one out to you in particular. I'm doing it by substitution. Either way I did this, I would wind up with something that's going to give me a contradiction, right? So it's going to be, math is trying to lie to me, and math does not lie well. It is a terrible liar. So in this case, I have my y is going to be substituted. I'm going to substitute in this 5x plus 9. So when I do that, I have a 5x minus 9 equals 4. Well, I collect my 5x and my minus 5x together, so that tells me negative 9 equals 4. Well, that's clearly a false statement. Which basically what that tells me is that these lines never cross. They are parallel to one another, which is why there is no intersection. That is when we get this whole false statement going on. Okay, we're saying it doesn't ever cross. So that, in a nutshell, is how to go about doing our systems of linear equations. And I wanted to make sure, like I say, that folks know that this was an option. You could also have it be where they are exactly the same line, in which case every point is going to be the same, right? So in that event, again, it's the same line. It doesn't actually, it doesn't intersect because it is the same line. There's infinite number of solutions. So hopefully that helps out. I'm going to end this now. It's, as I say, part 3 of lesson 8.